Good day everyone. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to the Systems and Analysis Design course. This is our 7th meeting, and in this session we're going to discuss about database design. In our previous meeting before mid-exam, we already discussed about data dictionary. And data dictionary is actually a good start when you want to design a database. Elements inside a database can be divided into these three: reality, data, and metadata. Reality refers to the events that happens in real. For example, business transactions events. Business transaction in the educational organization, such as in this faculty, refers to where students in the learning process is enrolling to courses. So this means that we have students and we have enrolling as a transaction, and we have courses. Students and courses here refers to what we call entity, which is objects that can be differentiated with other objects. It can be anything as long as it can be differentiated. Entity as objects has what we call an attribute. Attribute is characters that is shared among the members of the entity. For example, if the object is students, then the attributes should be student's ID, name, student's address, and so on. This refers to the attributes of an entity. If we convert this into a computer language, it will be a table that consists with columns. And then the second element is what we call data. The data itself actually represents the facts of the events. So in this case, for example, as the students is enrolling to courses, there are two entities, students entity and course entity. The members of the entity itself is the students and the course list, right? And each student represents rows or represents records inside the elements, while each rows has what we call the data value or data items occurrences. So this means that each member of the entity, for example, student A will have the data item occurrences as his name, which is A, and then his address, which is somewhere, and so on. And lastly, the one that explain the data itself, which is the metadata. So metadata equals to data that explains data. So in such cases, for example, we have the records occurrences. Now, the definition of each of the occurrences is actually the metadata. Such an example for data item definitions, student A has a name, and the name is actually types of data tags, while his student ID is a type of data ASCII or variants. And other than that, for example, address is also a type of text. And also we have what we call the data digits or data domain. So name has 30 digits and so on. So these are metadata that explain the definition of the data item occurrences. A database can be designed using several approaches. The first one is using data normalization. The condition for data normalization is where the company who conducts the transaction already have several amounts of data that is being saved. However, the data that is being saved in a file is still in an unstructured manner or not normal. This unstructured data needs to be structurized by using what we call the data normalization. We can normalize the data from the first form until the third form normally. The second one is the entity relationship diagram. The entity relationship diagram is fairly flexible so that it can be applied to any kind of conditions. A company that has no transaction at all, so starting designing from scratch, a company that has adequate amount of data inside their files, so similar with normalization, but use the entity relationship diagram, or a company that already have or established a database system. And the third one is the reverse engineering approach. Reverse engineering is basically a form of entity relationship diagram for companies who already established a database system. So the database system will be reverse engineered and converted into entity relationship diagram. Then the analyst and designer can improve or change the entity relationship diagram to further fit the needs of the company's business process. And then it will be converted back into the database systems. These are the notation of an entity relationship diagram. We have a square there, which refers to the entity, which is the object that conducts the transaction. We also have an associative entity there, which basically an entity that joins one entity with another entity, usually in the many-to-many relationship. For example, students enrolling to courses. This is an example of many-to-many relationship. The relationship, if we want to convert it into a database system, we need the associative entity, which is the study plan card. So students will need to input their courses in the study plan card. So this is the associative entity. Other than associative entity, we also have the attribute entity. The attribute entity is basically an entity that is derived from the attribute of the main entity. For example, we have students taking courses, and there's an attribute of semester. This semester can be derived as an attributive entity. And we also have the notation for the relationships of the entities and its restriction. The first notation here refers to where a member of the entity have to have a relationship with the member of the other entity. So always one relation. And the second one is where the member of one entity have to have a relationship with the member of another entity, but the relationship can be more than one. So at least one and then many. And the third notation here refers to where the members of one entity can have no relationship at all to members of the other entity, or can have one relations with a member of the other entity. And then the fourth one is also similar. The member of one entity can have no relations or one relation or more than one relation with the members of another entity. This is an example of a complete entity relationship diagram. In this example, we have a process where physicians treat patients. The first entity is the physician and the second entity is the patient. The relationship between the physician and the patient is that physicians treats the patient, and vice versa. The patient is being treated by the physician. Now, on the left here, we can see the attributes of the physician, which is the physician name, address, and so on. While on the patient entity, the attribute is the patient name, patient address, and so on. Now, if we look at the attributes, we can see the underlying attribute is basically the what we call the primary key. A primary key is a unique key that identifies the other attributes inside an entity. So for example, we have student ID as a primary key for a student entity. And whenever I call upon a student ID, then the student who has the student ID will probably notice and understand that he is being called. So it represents the student's name, student's address, and so on. Now, primary key itself has to be unique, so it cannot be redundant with any other attributes. And forms of primary key, there are several. We have the primary key itself. We have what we call the secondary key, or the candidates to be a primary key. We also have what we call the composite key, which involve two different attributes that can be function as a primary key. Now let's explain the relationship of each entities and the restrictions that applies to the relationships. In this case, the physicians here treats patients. There are three basic relationships between entities: one-to-one, one-to-many, and many-to-many. And physicians treating patients is a one-to-many relationship. We can try to simulate the relationship here. We have physicians and we have the patients. For example, we have physician 1, 2, 3 and patient A, B, C, D. Now, the relationship is a one-to-many relationship, and the restriction is where physician has to treat patient. The members of the physician entity have to have a relationship with members of the patient. It's a must-have relation, at least one and always one. So have to have a relationship. And vice versa, one or many patients have to have relations with at least one doctor. This means that physicians 1, 2, 3 have to have a relationship with patients A, B, C, or D. So physician 1 will have relationship with patient A, physician 2 with patient B, physician 3 have a relationship with patient C and patient D. So that's a one-to-many relationship. The restriction that patients and doctor have to have a relationship, at least one. You should be able to confirm the types of relationships between entities by using this kind of simulations. And next we will be talking about the database structure. Database structure have several forms. For example, a hierarchical structure, a network structure, and the most popular one is the relational structure. In this session, we're going to discuss a bit about the relational database design or database structure. Using a relational database, we can enforce what we call the database integrity. A database integrity consists of entity integrity, which refers to the requirement of the primary key for an entity. The primary key cannot be a null value, so it has to have a value. Other than that, we also have the referential integrity and domain integrity, which I will explain after this. And this database integrity is to prevent what we call the database anomalies, which can happen due to redundancy and update, deletes, and addition anomalies. And next, I will explain the database integrity and database anomalies using Microsoft Access. This is the Microsoft Access environment. I already prepared a couple of tables, the department table and the employee table. If we look at the design of the department table, we have the department number and department name. And as you can see here in the department number, we have the a key symbol here. So this means that the department number is the primary key of the department entity or department table. And next here is an example of domain integrity. A domain integrity will enforce validations to the data that is being inputted inside the database. For example, here the maximum amount of characters or digits that can be inputted inside the attributes here. This means that I can input a maximum of 256 characters for each of the attributes. I can also change the domain integrity amount. For example, here for the department name, I will change it to 50 digits. So that now the maximum number of characters that I can input in the department name is maximum at 50 characters or 50 digits. Next, we will look at the design of the employee entity. We have the employee ID here as the primary key. We have the employee name. But other than that, we also have what we call the department number. So the department number previously was the primary key for the department entity. Now, in the employee entity, the department number here now becomes what we call the foreign key. The foreign key is the key attributes that relates the primary key in the department entity with the foreign key in the employee entity. Each entity has their own primary keys, and one of the primary key of one entity will become a foreign key in the other entity. How do we decide this? The rule of thumb here is based on the relationship between those entities. For example, let's try to simulate the relationship between department and employee. And here we have department A, B, and C, and we have employee 1, 2, 3, and 4. The relationship here is where the employee work at. And in this example, each department will have a relationship with each employee. Department A has relationship with employee 1, Department B with employee 2, Department C with employee 3, and with employee 4. So this relationship refers to what we call the one-to-many relationship. The basic rule states that the primary key of the entity that has one relations will become the foreign key of the entity that has many relations. So in this example, the department has one relations with one to many employees. So this means that the primary key of the department will need to become the foreign key at the employee entity. Next, we will look at the referential integrity. First, we will look at the relationships of each of these two entities. As we can see here, the relationship is a one-to-many relationship. And here's how we define it. We can drag the primary key of the department entity and drop it to the foreign key at the employee entity. And in here, we can enforce the referential integrity. This means that we will prevent the anomalies from happening. For example, the addition anomaly, the update anomaly, and the delete anomaly. The referential integrity here refers to the relationships between one entity with another entity based on the primary key and the foreign key. For example, if we already have data in the primary key, for example, department number A01, and the foreign key also the same, department number A01. If the referential integrity is enforced, we cannot change or we cannot delete the data A1. Why? Because the data A1 is used by two entities or two different entities, which is the department entity and the employee entity. And this can be resolved. For example, if I actually still want to update A01 to X01, if the referential integrity is enforced, it will give me an error stating that the data is being used by another entity, so you cannot update it. If I want to change it or update it to X01, what I need to do is to change the requirements of the referential integrity previously in the definition. Just like this, I can change the requirements so that I allow any updates and deletes to the enforcement of the referential integrity. In this example, since I already allow those update and deletes to be done, now if I change the A01 to X01 in the department entity, and in the employee entity, the department number will also automatically be changed to X01 following the change at the department entity. So that will prevent the anomalies from happening, but it can also be changed as wise. That's all that we can discuss in this session. I'll be seeing you guys in the next session where we will discuss the user interface design and the control design. Thank you very much for your attention. I'll be seeing you next week. Good day. Assalamualaikum warahmatullahi wabarakatuh.